The first talk we have tonight is going to be from Carsten from the Cartesi project. And yeah, we can just get this rolling. Carsten's a baller. He rickrolls blockchains. He is one of the contributors to BitVM and obviously contributor to Cartesi as well. So take it away, Carsten.
Yeah. Thank you. Just let's see if this works. So I'm here to give you a small talk about something we're kind of like working on a little bit as a narrative in the whole modular space, which is basically talking about going from the world computer to the world cloud. And the good news is that basically we are in a place where we do have a world computer, and well, Vitalik is happy. But there's a couple of catches with this, because basically it's not as fantastic as many of us were kind of like hoping it would be. It's kind of slow, it's kind of like expensive, it's crowded, and this is a real website, by the way. It's awesome. And we kind of feel that this is not exactly able to support kind of like the different dreams that we kind of like had back in 2015 something to kind of like do things. And I don't know, but let's see if I can move this forward. I don't know, but honestly speaking, I feel like we are promised flying cars in blockchain, right? And we have that, like we were seeing just before on the animation, like you have basically in Ethereum have a single road, it's expensive transaction, it's single threaded and everything. But frankly speaking, I mean, this is how the future is supposed to look like. This looks much more awesome on my laptop, by the way, but the projector is how it is at the moment. And basically, let's start talking a little bit about what this tweet in this particular case, where Hayden Adams from Uniswap came out and talked about that rollups are basically just chains, and chains are just basically servers with superpowers like, and the red is my annotation here, thinks about being able to verify the history, which is stuff like sequencers and data publishing, like for example Espresso is doing. It's verification, as in calculating the state, which is like virtual machines like Cartesi, RISC-0, etc. It's something that's accessible to everybody, which is a quite interesting property for a server, right? And it cannot be shut off. And this is where technologies like IPFS and Ethereum kind of comes in to kind of anchor this. And these servers can talk to other servers, right? And this is where bridging comes in. And the thing about, if you look at kind of like the existing server landscape out there in terms of like, let's say, things that people are running on web servers and so on, they're typically running Linux. And I'll get to that in a moment why this is important for something like Cartesi. One of the things that, if you start thinking about, let's say, testing, okay. Thinking about something like a world cloud in this particular case. I think I'm too near for these microphones. Okay. Is that between these, let's say, servers that are in the cloud, in our world cloud in this particular case, we need a very good kind of like network interface between them. This is something like where sequencers come in, and this is a graph from like a table from the Espresso website, and basically what they're doing is that they're able to broadcast and verify that within, let's say, 1 second, basically you can call confirmation that, let's say, over 30 megabytes per second of throughput of data has come true. So it's very, very solid primitive for kind of building a world cloud. Where I'm from is the Cartesi organization. What we're doing is we're doing a RISC-V virtual machine. It's not a, like, let's say, a traditional emulator, anything like that, but it's like something where it's every single time you run this emulator, it ends up in exactly the same state when you're done running it. So it's completely reproducible, it's completely deterministic. It's something that has been developed since 2018. It's not something that's like, let's say, new in any kind of way or unstable or proof of concept. And it's general purpose. It's running the RISC-V instruction set. And essentially that means, in this particular case, that because it's general purpose, you can essentially run Ubuntu to it. A couple of kind of like technical details. You can basically persist state at any point during the emulator. You can optimistically verify it in something like an optimization game with minimal kind of subset instruction set. And for example, set in zero knowledge very slowly with something like RISC-0. It's programmable, and there's an API, and okay, I'm just going to move away from these because I think they're not helping. Okay. And in my not very humble opinion, basically the ultimate runtime for computation in something like a world cloud is a general purpose processor emulator that can run a full 60-bit operating system. Now, if we were to kind of imagine an imaginary, let's say, world cloud in this particular case, you can imagine something like Cartesi being let's say a virtual machine. You can have something like Espresso providing the networking as in, let's say, inputs coming from outside. You can imagine something like RISC-0 coming in and kind of providing the secrecy of execution, or let's say providing system proofs of things. Things like Filecoin for archiving, because, well, when you're broadcasting a lot of data, then basically you need to go ahead and also archive it because it doesn't get sustained by these sequencers. Technologies like, of course, IPFS to kind of access things like state, and of course Ethereum to kind of like anchor it. Things like witness chain is very good to kind of get, let's say, combined with eigenlayer to get a kind of crypto-economic guarantees on things. Okay, let's see if this works. And I kind of think that, let's say, a real world cloud is basically one where you can take an existing Docker container, and within 10 minutes of kind of starting to develop with this stuff, you're able to deploy it, you can interact with it, and you can basically start working with it straight after. I mean, that's the kind of goal we have to get to. It's the goal of something like uploading to AWS Lambda or to Versal or something like that. And why can't we do that with blockchain technology today? And I just want to kind of like show a small sneak peek, and this is not going to be a 10-minute video. I'm going to kind of like skip into it. But like, let's say, imagine a small dev kit where essentially downloading one Docker container, it gets you, just a sec, it gets you an in-browser development environment where you can take an ordinary Python file together with a Docker file. You can go ahead and build it. And this is a little bit of the slow part of the process. Basically end up with something that's deployed to IPFS. It's a Genesis state. You can synchronize to it anywhere. And you can verify it with, let's say, different technologies, like, for example, witness chain or so on. And basically, the moment that this chain CID that you see down here, I'm not sure if you can actually see it, you can actually synchronize to it. You can send transactions to it straight on something like Espresso. You have allocated virtual machine ID on Espresso. And this is kind of like what we're working on at the moment that makes it super, super easy to kind of like take existing development tools, existing programming languages, and actually put it into something like a blockchain development environment. And basically, just to summarize what you just saw, a kind of sneak peek of an in-browser development environment, a Python tree-based function. I just add a simple Docker file. I build that container for the RISC-V. I make this container streamable on IPFS. I get a namespace on the Espresso Gibraltar testnet. I upload this Genesis state to IPFS, and now, at any point now, just by having this Genesis state, that can go ahead and send transactions to this build chain. It gets processed using this Python function in a kind of verifiable, reproducible manner. And, well, you can synchronize up to it, access the state over something like IPFS, because the state of these machines is stored into IPFS instead, in just 10 minutes, right? And what I'm trying to kind of like say here is that basically there's very little amount of people out there in the world who basically has any, like, they don't have an excuse for not spending 10 minutes to at least try out the technology, right? And I also want to say this, that it's also, there's no more excuses for having a bad blockchain development experience anymore, because frankly speaking, we're an industry, we are really good at making horrendous development experiences. And what you just saw is powered by the Cartesi stack, Espresso sequencer, and IPFS, and it can be verified with many of these different technologies I was talking about before. And if you want to have more information, well, you can poke me on Telegram, on Twitter. You can talk to us here. We have Cartesi t-shirts on. If you want to know more about Cartesi, the Cartesi machine, you can do this and use these URLs. And you can join our Discord for any kind of technical discussion you want to have. That's basically it.